everyone. Welcome to Machina. It looks like I'm interviewing 4 robots, but who I have here are the founders of these companies as well. And see, we have a couple more people coming in. I'm Justina Chung. I'm with Bessemer Venture Partners based in London, where we invest from seed companies all the way to growth across the layers, from robotic models to infrastructure and the robot makers. And on the panel today, we will discuss the realities of deploying and running robots at scale, and who better to do that with than 4 veteran operators in the space. And so to start things off, I'll ask each of you to do a brief introduction, but also to set the stage and the context for the audience here. You know, what form factor do you work with? What's the use case? And where are you at in deployment?
All right, I'll start. Thanks so much. My name is Peter, co-founder and CEO of ANYbotics. So the picture on the very left, what we build is inspection solutions based on robots for the process industry. And the reason is, in the process industry, it's all about asset integrity, running the facilities safely, but we don't have enough people. We cannot put sensors everywhere. So what we're doing is sending in robots with 4 legs, because they can maneuver through these complex environments, carry a lot of sensors on top, visual, thermography, acoustic, gas detection, you name it. They run fully autonomous, and then they run daily, hours on hours, collecting thousands of inspection points. And based on that, we're building the AI to understand what's going wrong, notify the operators, and tell them what's happening, such that they can take action earlier on.
Hi everyone, I'm Tristan, co-founder and chief product at Nomagic. At Nomagic, we're actually not having robots that move. They're static, but they're focusing on manipulation. So we're doing item handling in warehouses. Those are generally industrial robots that we install. It's like solutions that are 1 or 2 robotic arms. They can use multiple tools and do all kinds of item handling and item manipulation, first in fulfillment warehouses and basically expanding progressively to other types of warehouses.
Hi, I'm Tomaž. I'm one of the co-founders and the CEO of Sunrise. We do intelligent robotic cells for high-mix, low-volume manufacturing, deployed mainly in electronic manufacturing services now, but we'll do a lot of other stuff. And our product looks a little bit like this, so much more like a machine than a traditional robot system, with tons of cameras, lots of edge compute, and 2 arms to poke the world around us. And we get them to work by visiting a customer facility, taking lots of video, and showing up a couple of weeks later with this machine just ready to get to work. So happy to talk about how that looks like in reality.
Hello together. Nice to meet you all. I'm Björn from Schaeffler. We call ourselves the motion technology company. So we mainly serve in automotive and industrial sector. And due to the fact that we have over 100 plants in the world, automation is really important for us to drive our operational excellence. In Schaeffler, I work in the innovation field. So we, in the end, translate early technologies to our production plants. And so we drive mainly their automation with different form factors, from conventional industrial robotics up to humanoids, which you see on the picture. So this is one use case we applied in a plant in Germany, where we brought really physical AI to our production world.
Great. Thank you, everyone. So we're going to talk a lot about the friction involved and ways to reduce time to value in what you do day to day. But to start and kick things off, maybe let's start with war stories. Give the room a sense. And I love that we have panelists across different form factors and fields here. What was the hardest, the most challenging deployment you've worked on, and what helped to solve that?
I can start if you want. So the most difficult is generally at the beginning, right? Because when you're early in your journey, you make lots of mistakes, and in hindsight, they look like all rookie mistakes. So the second customer we had, which is Bragg, it's the second largest e-commerce platform in Switzerland. We installed our first couple of robots there. And in hindsight, I'm thinking everything was wrong there, right? So the layout was suboptimal. We're supposed to do a preparation of orders where we're picking from one bin and placing into another bin. There are small details, like the distance between the bins that they've set up was 1.5 meters. And we told them, well, how about we put the bins next one to another? It's going to be just making the process much faster. And they told us, yeah, but we don't care too much about speed. Well, never trust that. right? We don't care too much about speed. You know, you don't care too much about speed until this thing is productive. And then at that point, you'll care only about speed, right? And so you're basically learning the things that, you know, it's the usual product management thing, right? Like you need to listen to the customer, but you shouldn't listen, you know, without a little bit of a grain of thinking of what is the long term for them, right? So there we had to change the layout. We had to change the robot brand. We started with a robot that was like operating well, but not to the reliability level you want when you're running 24/7. We had to change the tools. We're operating with one tool, and over time, you know, we need to take millions of items. So it's really the iteration that matters, I think, is the message, right?
Maybe on our side, I mean, by now we have hundreds of deployments, and everyone is always different. Imagine you're sending in robots into complex environments. There's grass growing, there's snow falling. There's always something, right? One of the deployments for sure was challenging because we're working in aluminum production, and the floor is so oily. You've never seen that. Even people hold on to the handrails, and that's decades of oil built up and still producing, just coming off the machines. There's no way to clean it. It'll get oily again. And the robot actually could handle it, but they slipped around like ice skating. So locomotion was okay, but because suddenly the odometry is, you know, the input is not correct, so the navigation, so the whole thing was just very difficult, let's say, and something you cannot, you know, simulate, something you would really not expect from, you know, normal facilities. The trick for us was to send engineers out, right? First-hand look, gather the data. The customer was very patient with us. Then over time, iterated on it, eventually deploy a new model, update it, and now it works flawlessly. But it's been a painstaking process.
Yeah, from our end, I mean, I have tons of worse stories. I'm going to pick one serious and one fun, right? So I'm going to start with a fun one. We deploy the cells and we train them before they arrive to the customer facility. So the idea is for them to get productive on day one, right? And mostly we succeeded with that. But in a weird case, we had this fluctuation of performance because of the safety system getting triggered all the time and so on. And you know, we look at the cameras, we look what's going on around the cell, nothing. Like we can't see anything wrong, but there is this fluctuation of performance happening. And so we send one person to do an eye test of what is going on here, right? Like, I don't know, it's a power going up and down or whatever. And the person comes there and stands in this facility, and there's air blowing behind them. And so they turn around, and there's a huge industrial fan behind our cell. And they turn around again, and they see a trash can with a flapping bag in the trash can that was triggering the radars. And, you know, there is no model simulation. You know, you can iterate on this on the product side forever. I don't think there is an edge case where someone says flapping trash can as part of your product requirement or application requirement document, right? And so obviously, you know, now you know there is trash can, you fix that, and then performance is good. So this was a fun one. On a more serious note, same thing, like you said, you know, numbers, right? So we start working on an actual production line. Again, deploy goes really well. We get it up and running quite quickly. And, you know, I'm not going to use real numbers here, but just for the sake of conversation, let's say that the target was 50 parts an hour, right? And we hit the target, life is good, you know, everybody's celebrating and so on. 2 weeks in, the customer calls us and like, hey, we need 75 parts an hour now. And obviously we look at each other and we're like, all the tricks we used for 50, like now we have to get out of the window and kind of figure out a 75. So we figure out a 75, right? But how do you do that without changing the hardware, without changing anything? Like that's the interesting challenge that you start facing. And when you fix it, like what happens again, it's like, now we need to do 100. And so I guess the biggest learning there is do a really good job at collecting the data ahead of time and then 2x whatever anybody tells you and you know, build for that.
Yeah, surely also prepared one story. We always try to bring in new innovations in the field of automation into our production plants. And we also had one example where we did the base development. It was an AI-driven approach where we had a reinforcement learning approach to insert gearboxes. We did the base development in our innovation center, and the process itself then worked. And we were like, nice, and now let's go to the production side. And then the fun starts because you have to think about so many other things, like the vertical IT integration, like the safety concept. Then you have a dynamic environment. The layout looked a little bit different. So we had vibrations from a conveyor we hadn't in mind. So this was kind of a tough time. We solved it surely, but this really showed that the thing you do in your innovation center or you do in the pre-development phase, you really have to challenge or to match with your real environment. And I think even today with the new simulation capabilities we have now, we did here a big step or do here a big step to have a better engineering, a better pre-commissioning, and I'm really looking forward to that new technologies because I think we can close step by step this gap even in the future.
Great, thanks for all that. I'm getting the common theme is expect the unexpected. And there are some things that you can plan for ahead of time as well, getting the telemetry correct, for example, but other things like, plastic garbage bin flaps that are just not possible to predict. And from the audience, I wanted to get a feel for where everyone's at. So, who here has like robot fleets and deployment? Hands up if you work in a place that does that. Okay, a couple hands up here. And who here is doing it for the first time or, providing services or, models to enable that? Okay, great. So I think there's, a lot of lessons I think that can be, shared. And one of the questions I have is, if you were doing this for the first time, what would be generalizable advice you could give to the audience here? The telemetry is one point. Is there anything that you would do again from the start to get right and shorten the process?
So I think there is a general learning that comes from what Tomaž just said, right? Like is go to production as soon as possible, right? So I think until you face production, you're just playing with a toy that is providing zero value. Right, and I think this was very clear for us. When we started with our very first customer, we set foot on their facility from day one, and we started to test with their items. First, not on the production line, but the aim was go to the production line as soon as we can afford to, and afford to means we're not breaking anything, right? But of course, as soon as we can afford to means we're not yet ready to be, full-time without anyone near that robot, right? But the painful times initially on the production line to learn all the edge cases and make it work are invaluable because the edge case you see there and the types of problems you see there have nothing to do with what you actually imagine in the lab or could do in a simulation.
Yeah, go ahead.
For us, certainly one of the hard learnings was, do you have everybody aligned to agree on the problem, right? If you deploy a robot and everybody was like, cool, and now what, right? And so it turns out you haven't really spoken to IT yet, the union, cybersecurity, safety. So in average, it takes 5.4 people to agree on the problem. That's the most difficult part, right? So front load as many of the decisions and agreement as you can before the robot even shows up. Because the robot showing up, that's the easy part. The agreement to the people, that's a tough one.
Yeah, I'd echo that. So I think, people think that robotics is a problem of models, that it's a problem of like, hey, can we get general intelligence and so on? But I personally feel like it's a logistics and operations problem equally as much. And that said, I think for us really is we are good at research, but we are even better at productizing research. And so I think, a lot of the stuff you would see on Twitter or in a demo video and so on, that is great. But if it doesn't work with at least 3 nines of reliability, like you don't even get to the starting line in an industrial environment. Because if you need an intervention like every hour of the day, that just doesn't fulfill the economic promise, right? And so if you go in an industrial environment early, you learn that where the starting line is, you learn that there are probably 3 really key areas where you need to excel. One is robustness of the system, so it needs to run for thousands of hours without any errors. It needs to be autonomous for a long time because otherwise you aren't really fulfilling the economic promise. If I'm selling you something that enables you to unlock a person and move them to a higher value station, but they still need to tend the machine every 10 minutes, like that's probably not a real economic value right there. So autonomy is really important. And then I think the third one is making sure flexibility. I think that's another one where a lot of projects, and you will probably know, it's deemed to be, it's a 5-year thing. We're going to run it for 5 years. There's going to be millions of parts and so on. But the reality is like 18 months in, the market tells you you need to change something. And then the big investment doesn't pay off. So you kind of have to keep that in mind as you deploy, that you are going to have to be flexible down the line. And again,
Yeah, can agree on that. That it's not only your technology who has to be ready, also your ecosystem in which you integrate these technologies. But also, and you mentioned that flexibility is also a key driver in our production, how we design productions, because we see the markets, we see the e-mobility, for example, the predictability gets less and less. And so we have to identify, or let's say design productions who are modular, who are configurable, and also then the automation solutions. And we really believe, because we have so many scenarios we have to think of, what if, that we also have to do the simulations. And surely simulation you can do on a layout level, but also on an automation level. And with partners, which are also here, we try to simulate this context-sensitive environments to really have an early, let's say, commissioning, or let's say a validation of this process. Surely there's a sim-to-real gap, and this is then where it close the loop to you, that you have to go to the production, that you have to do your reality capture, but then use the simulation tools we already have and which we're advancing to do this pre-check and pre-validation in virtual world before you go into the real environment.
Great. And when it comes to deployment, in the sense of getting prepared and getting everything aligned before the robots hit the floor, the time to value can be extremely long in some cases, even putting aside when things don't work and unexpected things happen. And so when you think about that process from installation to the data integration to training the workers there to work with the robot and all that before live deployment, would you approach this in terms of building in-house, working with partners, or is there a way to streamline some of this? I think Björn mentioned simulation as one part of it. Which approach do you use today?
For us, it's the sequencing, right? Because this is a new market, customers know their problems, but they don't know how to use this solution, right? So for us, we do it fully in-house, meaning that we built the hardware, we built the AI on top of it, the capability software, but also for us to work flow integration, that is key to how we think, the ROI modeling, all of that. And there's, by now we're as proud of all this innovation in the go-to-market as we are on the technology. Now, in the beginning, that's okay. You need to be really good at it, 200%, because if you hand it over to a partner, half of it is lost in translation. We have seen this before, and so if you're not at the 200%, right, they can do 100%, but if you're at 80, if you're in the beginning, it'll not work. So for us, it's clearly a sequencing problem. In the beginning, do it yourself, direct, so you learn the quickest.
Yeah, I think 100% on this, right? Like this has been our conscious strategy, which is going direct to customers so that we learn all the ropes and we build the playbook, and so that we progressively transition to have integrators and partners who can now bring our solutions themselves. But this is always kind of a learning for me in channel sales, that you should always assume that a channel sale partner is basically someone who may not understand your product, may not want to sell it, and have little interest in its complete operations. And if you go with that mindset, well, you build basically a playbook, a product, and a system, and your own control of the operations that is fail-safe from that point of view, right? So in many cases, you may have integrators that actually do a very good job, right? They'll do an even better job because you have all these backend. If they don't, well, you're still safe because you've built all those layers.
Yeah, I would add that you have to start, in my mind, from day zero, kind of building a product that allows you then to do these things fast, right? What you described. And so think about the entire kind of journey a customer is going to go through. Like, how often are you going to see them? What data are you going to acquire? Where? What are the aha moments? Let's say for us, we, from the very beginning, like, we believe there were two real aha moments. One was when they see what we call a digital replica of their workstation, that it's the exact same workstation they have human tend to today, tended by our cell with no changes. A couple of days after we acquired the data, that really bridges the imagination gap between, oh, it's like this today and it could be like this tomorrow, and you can do the math around that, and it's not going to be precise, but it is going to be indicative of what you can expect. And then the second aha moment is like, okay, when the machine arrives, can you get it to work within one shift, right? Like that is magical. It's kind of like I tell to my team that what we are building should we feel closer to a kitchen robot than a system that you wait 18 months to see move. Like you buy a kitchen robot, you plug it in, and you can You can do whatever, pizza dough, 5 minutes later, right? So that's super important. But then what happens after, I think, is equally important. So things will go wrong, as we discussed earlier. So can you build a system that collects those anomaly data and automatically gets better through time as a fleet, right? That's an open-ended question, but I think people building self-driving cars have showed us that it's quite possible. And so we are doing a lot of work on that front, where the more cells we have running, the more data we collect around anomalies, the next one just gets better from all of that.
To add up here, how we position us as Schaeffler, like in the end, you have to think about the technology readiness levels. Like we have this, let's say, conventional industrial robots. They're in our productions, they run 24/7, but then we also have these new and latest technologies in the field of humanoids. So you have to have the right partners on that journey from, let's say, the low technology readiness level up to the high technology readiness level. And surely we're a technology company, we're the motion technology company, so we want to understand and we also want to develop technology, especially in that field of automation. So we work with external partners, with a lot of startups, but also we have, let's say, one unfair advantage. We have one big special machinery in-house. So imagine we have 100 plants, and in every plant we have many, many production lines. And they are mainly built from our internal special machinery. And the cool thing is that we can develop with them also new production line concepts and also these kind of automation solutions. And in the end, they built and integrated into this ecosystem. So it's a big chance for us also to boost these kind of new automation technologies, but also to bring in existing technologies. Like we started a few years ago with cobot activities. Then we moved to HEVs, and now more and more humanoid robotics applications are coming. And this we do in this close partner network with externals, but also with our internals. And this is kind of the unique thing. We have on the one hand the integrator position as Schaeffler, but also we have it as a user. And I think you all heard the presentation of Dave Kerr. We also provide components to humanoids. So in the end, we have the full playbook here and have a deep understanding in production and then also in the systems itself.
Björn, how do you decide between what you keep owning internally versus working with third parties? Are there certain parts that are more core and more important? I think we talked a little about, being close to the customer, seeing it day to day, and once you get a really strong sense of things that are repeatable, then maybe partnering to scale up. But how do you decide what to keep and what to outsource?
Coming back to that technology readiness level discussion, like I would say in the earlier stages, we're very open. We look for external partners, and because like there are everywhere new innovations and solutions in the market. Also here, I saw some nice things already, and there we had to have a look outside, and then step by step, sure, we have to run our production 24/7. We have to make money in our plants, and there we look more and more with our SMB, and also the special machinery, they also work with external partners, so they don't do their own cobots or robots. We also buy them and integrate them. So it's a technology readiness level discussion you have here.
Okay, got it. I want to move the conversation towards what you see when you talk with buyers. What are the main considerations they have? We talked a little about, sometimes, they're more focused on, initially it's not speed, and once it works, it's all about speed. So what are you seeing on the ground? What considerations do they have? And also, maybe a more specific question, when you have a couple of robots in pilot, how do you move it towards full-scale deployment across the org? Is there a threshold or particular performance metric or ROI? Put another way, what does like best of look like when a client that really loves the product is seeing real value and robustness come from the platform?
Yeah, I think at the end, right, like the core of it is an ROI sell. Right, like you're building automation because you want to find ROI, you want to find value, and so what matters is to have really that discussion early on to see what is going to be the return on investment, what is it going to depend on, right? And customers will be more or less open to share all their numbers because of course, right, it's part of also of the negotiation eventually. But you need to build a certain level of trust so that at least the core components are clear. So that you can have that discussion about what is the throughput at which you're going to get this ROI, and what are the exception cases that may happen, right? And how do we handle those, right? And I think if you define that well, then you should get into a situation, which is what we tend to do, where we actually never sell pilots. We always sell in the format of what we call 1+X. So basically, if I come to you, you're my first customer, I'm not going to say, hey, I'm going to install a pilot, and then we'll see. I tell you, we're going to sign a contract for, let's say, 20 robots. But if you're worried about the fact that it's 20 robots, the large investment, etc., let's do one first. We put all the conditions under which, if this thing works, we scale to the 20. And these fronts a little bit of the difficult discussions, because it forces the customer to say, well, what are the things that are like the absolute condition under which I'm ready to scale, right? And this becomes contractual. But that's really a time saver afterwards, and forces alignment within the organization as well on the customer side.
100%. We do the same thing, right? In the beginning, it's about was POC and pilot, but what are you trying to show, right? Ultimately, can you define the problem and can you solve it? And so there's an approval phase. I still get that, right? So 2-3 months, can you hit those KPIs that you agreed on? But from the beginning, the 5.4 people I mentioned, right? You need to have clarity. How do you fit into the company strategy from C-level? VP Health and Safety, right? How the unions, how is all those people, IT wants data, right? Everybody has a stake in this. And you need to have clarity from the beginning, the big picture, how big is this opportunity together? And then you embark on a multi-year project with milestones. We need to do certain things and fulfill them, but also they need to do certain things, right? A pilot where just a robot runs, that's clapping, but who takes decision based on the data we have collected, right? That loop needs to be closed and people need to see the benefit, but that work, a lot of it needs to be upfront.
Yeah, I agree on that. Like maybe my view is a little bit different because we sell to a different type of customer, right? Like just for the audience, maybe, I believe you sell to very large companies and very large logistics centers. Like we mainly serve the high mix, low volume manufacturers, so your typical European SMB industrial, where the 5.4 people is the entire leadership team. So there's a fewer people, and some of these people on the leadership team have the same surname as it's written on the building, so you kind of know who makes the decision. But jokes aside, our model is basically quite clear what the ROI is, because we price it as a service on a particular number that is the equivalent of roughly 2 operators in the most remote part of Europe you can find, and roughly 1 operator in France, UK, or the western part. So it is, the economic promise is like, there's huge labor shortage, so you don't have people anyway, and we'll help you bridge that. And the people that they have, they generally like, and they would want to move them to do higher value work. And so it's an easier conversation from that front. But I agree with you, avoid pilots, avoid proof of concepts. Like we also sign like 3-4 year deals straight away, and obviously with thresholds, so we stay in. But the ROI conversation, what we realized was that if we make the number simple, like that is easy to understand. Because obviously, as you know, all these systems are very good at counting, so we could meter it per part. But for our customer base, telling them, hey, tell me how much it costs you to get this piece from here to here in the process would be a month-long homework. And you generally don't want to do that to your customers, right?
Yeah, to add up here, we have the value-driven approach. We have this discussion about shorter labor shortage, but also quality is a thing, and process robustness. So if you have a solid automated process, you somehow can ensure a higher level of quality and also process stability compared to manual workforce. And this is also key because we see quality as one key measure for our customers, and we also have a look on that. And furthermore, also when you have this repetitive and task with high payloads, we also have a look on the ergonomics. So when we can improve ergonomics, we also have a look on the way that we can automate this process to sum it up. Nevertheless, and this is a thing, when you think about scaling, we said the ecosystem must be ready, the technology must be ready, and in the end you have to be able to adapt very fast because we have many changes in our layouts, we have many changes from production lines, customers, products, and you have to adapt in an efficient manner. And I think this is also key, that you're able to, let's say, adapt and, let's say, bring in these automation solutions into different cases in a very efficient way.
Can I add just one thing there? So
yeah, go for it.
I think we missed a very important actor kind of in this whole story, which is the operator on the floor. We talk about the leadership making decisions, buying, and so on. But at the end of the day, like what we realize is that who keeps the cell running and all of that is the operator, and so they also need to buy in And I think the design of the product and how much care you take about the experience really influences that. So it's an early bet that you should make, and I think it pays back significantly.
And then you're totally right with this cultural change. So like in our regions, we have different technologies which we push, and you have, let's say, different states of innovation there. And if you're in a plant where they have their first HEVs, they're like, oh, what's this? And then you're in pilot plants or in lighthouse plants where you already have big fleets, and you see how the operators interact completely differently because it takes some time for this kind of change in that environments in where they work. Yeah.
Also, an additional perspective, I'd like the room to think about. Right? In robotics, essentially we're doing work, especially humanoids, right? It's about labor replacement. But I think robotics can do more, and we need to ask ourselves, you mentioned quality, right? How can we do a better job than a human at that task? And so for us, the ROI is not replicating what humans do. Yes, there's not enough people and there's a few hours saved, but the big ROI comes from, can we find problems earlier than a human would? Because people don't see temperatures, they don't hear the sounds from the machines in an ultrasonic range, all of that, and not for sure not at the precision of a robot. So for us, the ROI is very quickly in the 10x fold, in the millions, because we stop downtime, which is in hundreds of thousands per hour, right? So always think, what's the true ROI? Labor replacement, I think that's a small one, and that shouldn't be the ultimate aspiration.
Yeah, I love that challenge to see what beyond human capabilities, way of extending that to, say, dangerous environments or capabilities that our five senses are unable to perceive, just beyond the pure replacing the unit of work hours that humans are able to perform. I know we're quickly running towards the end of the panel here, so we'll end with a quick round robin. Your hot or very sensible takes on what is the biggest misconception that you think people have when it comes to deploying robots at scale?
So maybe I'll say thinking that it's about one thing. Right? Like I've heard so much that people say, oh, our company is about reinforcement learning, or my company is about that. Well, if you want to have a successful robotics company, you're going to have to be right in a lot of things. So that's the short take, right? Not just one thing.
I can also keep it short that scaling is duplicating use cases. It's not that simple, as we heard from this discussion. So yeah.
For us is, robotics are standardized, and a lot of robotics companies believe their world is as well. But if you go to every plant, everything is always different. IT is different. People are different. Culture is different. So there's a mismatch between standardization, robotics, and the reality.
Yeah, I think the misconception is, or not a misconception, but perhaps some people that don't realize that in robotics, I think you need to go very slow first so you can go very fast later. Because if you front load the solutions to some problems, that will allow you to then move much faster. And once you have hardware out there, it's pretty expensive to replace. So that piece, you should do right. But then you unlock kind of all the potential of the software. So I think the future of all of the stuff we're talking about is going to be much closer to self-driving than to the traditional robots moving stuff point to point. And I guess you can go see how that took 20 years to get right. Or not even. I mean, it's not even right yet.
Okay, and last quick take before we break. What is one capability you're excited about which would unlock a step change in that time to value and deployment? Is it a technology development or something on the horizon?
From our perspective, our robots are still, assistants. The humans tells them what to do, and they can do it reliably. However, I'm excited about proactive physical agency, world models of the topics, when you truly give contextual understanding to robot and you unpack it, and the whole deployment process becomes automated because the robots have seen thousands of hours, thousands of different facilities, and they become an expert, not only an assistant.
Yeah, generally excited about the steps that are about making deployment much faster through having duplication of your physical robotic cell that is like millimeter precision, right, on the simulation, and being able to apply these to just make the deployment faster.
Yeah, I'm personally very excited about a sparse universe of point technologies that are coming together, right? So similar to what you said, anything from the progress that is happening on data capture, 3D reconstruction, world models based on physics anchoring, leading all the way into AI-driven robotic control. And when you put all of that together and kind of start closing some of these loops, I think the world is going to look quite interesting. And we're not that far away. I think we're a couple of years away from this being the reality.
Can I add to this up? I'm also super excited for this whole chain from reality capture to the digital engineering and then to efficient and fast deployment into the real world. So really looking forward to that, yeah.
Yeah, it really feels like the talent, the developments, the scaling laws is positioning us to crack these problems in the next few years. And I'm excited to see the vast adoption deployment curve at that point. So with that, thank you very much to all our panelists and enjoy the conference.
Thank you. Thank you.